Introducing the SCX Smart Replenishment Orchestrator, your powered solution for optimal inventory management. In today's fast-paced, complex supply chain environment, making optimal replenishment decisions is crucial yet challenging. The SCX Smart Replenishment Orchestrator is an advanced reinforcement learning agents platform that autonomously orchestrates these decisions while factoring in production schedules, inventory levels, transit timelines, capacity constraints, and demand forecasts. It continuously learns and adapts to craft the ideal replenishment plan. We'll dive deep into the orchestrator's robust features and see how it optimizes replenishment under three different strategic objectives: revenue optimized, fair share, and priority optimized. We'll explore its intelligent demand forecasting, constraint-based modeling, and user-friendly interface that puts advanced optimization at your fingertips. With our intuitive user interface allows you to see the results of autonomous replenishment runs by selecting from hundreds of shipping locations, distribution centers, and millions of materials. You can also choose the review period and one of three strategic objectives. Revenue optimized, which maximizes total revenue by choosing the best shipping plan for each distribution center and material. Fair share, that distributes inventory proportionally based on distribution center needs and priorities. And finally, priority optimized, which prioritizes high-priority distribution centers first, then fills remaining demand at other locations. For the purposes of this video, let's walk through a real-life example using our orchestrator. We will execute online the Replenishment Orchestrator to understand what happens, remembering that in normal day-to-day operations, the application is run autonomously in background, automatically selecting the best optimization model for each stock-keeping unit, supplying plant and distribution center combination. First, we select our supply network nodes. For shipping locations, we'll choose the Chicago Production Center, Atlanta Manufacturing, and Denver Production Hub, our key manufacturing sites. Next, we select our distribution centers: Northeast Regional Distribution Center, Southwest Distribution, West Coast Center, and Midwest Distribution, covering our major demand regions. Finally, we pick the materials, such as SCA 10012, CBB 20050, and CSC 3036. In the orchestrator, you have the flexibility to set the review period, which determines the interval over which inventory levels at the DC are assessed or reviewed. The interval period, lead time, and average demand in the review period is used to calculate the target stock level at the DC. In this demo, we'll set the review period to 5 days. In the background, the system will automatically select for each material one of the three optimization modes based on rules provided by the business. For demonstration purposes with our network set, we choose to optimize for maximum revenue. Now the orchestrator will create a replenishment plan that drives the highest total revenue, prioritizing the most profitable stock-keeping units and distribution centers. With our supply chain network set up and the optimization type selected, it's time to put the Smart Replenishment Orchestrator into action. When we click the Run button, the system springs to life, processing vast amounts of data and complex algorithms to generate the optimal replenishment plan. Here we get all the shipping details table displays all the critical information, including distribution centers, location stock, material, destination, priority, target quantity, distribution center stock, needed quantity, replenish quantity, cost, unit price, arrival date, ship date, and lead time. By leveraging the intuitive filtering options, you can effortlessly slice and dice the data based on your specific criteria. Whether you want to examine a particular distribution center, track a specific material, or analyze shipments within a certain time frame, the Smart Replenishment Orchestrator makes it a breeze. Taking a closer look at the results, we can see that Northeast Regional Distribution Center is prioritized, receiving 100% of its needed quantity of the high-value SCA 10012. This distribution center offers the greatest revenue per unit at $50, which a 2 days lead time. The orchestrator allocated the limited supply to the most profitable opportunity. Diving deeper, we see the reinforcement learning agents demand forecasting driving these decisions. Specifically for each stock-keeping unit at the distribution center, the orchestrator tests multiple predictive models, like Monte Carlo simulation and ARIMA, on point-of-sale demand data and selects the best predictor of demand based on the historical date here. It chose Monte Carlo for its ability to model complex probabilistic demand. We can see how using this model, the calculated historical has a strong correlation to the actual demand. Other models, such as MDP or DeepQ networks, don't fit the actual demand line as closely, so the system automatically selected Monte Carlo and displayed its data. Having selected the optimal forecasting model, the system is able to derive the average daily demand. Using this number, along with the lead time and review period, the system calculates the optimal target stock level for the distribution center and stock-keeping unit being analyzed. With enough sufficient data, we can go a step further and predict demand by week instead of month, showing the different models' predictions at a more granular level. This provides an even more accurate demand pattern. The orchestrator, when run in background, will automatically test the historical demand against monthly and weekly profiles to determine the best time profile for the demand. Based on the historical data fed into the model, the system chooses the best model for prediction as well as the best time granularity. In this case, the chosen model is Monte Carlo simulation, in an attempt to get the best correlation to the actual demand. The system transparently shows the reasons why each model was not chosen, providing insight into its decision-making process. The distribution map is another essential feature, providing a visual representation of the routes between shipping locations and distribution centers. The line thickness indicates the quantity being moved. Thicker lines mean larger quantities. Lastly, the summary shows the total shipped units, 54,900, total cost of $208,000, and total revenue of $4,154,500, providing a high-level overview of the plan's impact. Once you're satisfied with the plan, you can immediately execute it. By pressing the Publish button, the orders are replicated to the ERP. The optimized replenishment decisions are then distributed to the back-end ERP systems, ensuring the right stock reaches the right place at the right time to maximize revenue. As mentioned earlier, in day-to-day operations, it is possible to initiate the publication to ERP systems autonomously as part of the background run. Now, we will run the same simulation with the same shipping locations, distribution centers, and material while exploring the fair share distribution. In this mode, the orchestrator aims to equitably distribute inventory based on each distribution center's demand, ensuring all distribution centers receive a fair allocation and no distribution center is left understocked. This plan shows a more balanced allocation. While no distribution center gets their full requested amount, they all receive a substantial portion of what they need. High-priority distribution centers still get a bit extra, but overall, the inventory is split more evenly. This mode is ideal when equitable service across the network is the top priority. For example, Northeast Regional DC requested 7,000 units of SCA 10012, but received 5,800 units, leaving a deficit of 1,400 units. Another example, Southwest Distribution requested 6,200 units of SCA 10012 and received 4,900 units, also resulting in a deficit of 1,300 units. In the summary section, we can see that the total shipped quantity remains 54,900 units, while the total cost and revenue may differ slightly from the revenue-optimized scenario, as the allocation prioritizes fairness over pure revenue optimization. Now that we have covered all functionalities of Seeloz SCX Smart Replenishment Orchestrator, we want you to experience firsthand the precision and reliability that Seeloz SCX brings to your operations. By harnessing the power of our advanced intelligent platform that combines reinforcement learning agents, machine learning, and generative AI to deliver optimal inventory management solutions. It empowers businesses to optimize their inventory planning and execution like never before. Join us in turning supply chain chaos into confidence. Visit Seeloz.com and take the first step towards precision.